Hello everyone, welcome back to my YouTube channel. So in this video, we will be studying about the disposal of sewage effluents. This is a very important topic of environmental engineering, although the questions have been very limited in the previous years of GATE, but since in every year the GATE authority updates the syllabus, they keeps on changing the pattern, they keep on updating the type of questions they ask, so there is a very high probability that the questions may be raised in the coming years from the topics जहां से अभी तक क्वेश्चंस बहुत कम आते हैं, वहां से क्वेश्चंस आने की संभावना ज्यादा हो सकती है. So let us study this topic. First of all, I will be summarizing the formulas. I will be brushing up your memory, and after that we will be taking up one numerical from some standard book which covers everything about this topic, and one question I will take up that has been asked in the previous year question. A very simple question has been asked in the previous year question, but I will take up a question that is very good and that will cover everything regarding this particular topic. So let's start with this particular topic. See what happens. This is a kind of curve that is between the oxygen. This is called as oxygen deficit curve. At any point of time, at any instant, this represents the oxygen deficit. So let me explain this curve to you. Importance of this curve. See what happens. There is some river stream. This is a normal river stream that has a saturated dissolved oxygen. Dissolved oxygen is at saturated level in this river stream. Now what happens? Some effluent, wastewater effluent is added to this river stream. The discharge of that sewage is QS. The discharge of this river is QR. This sewage is usually assumed to have dissolved oxygen as 0, okay, but it has some BOD, it has some organic content that has some BOD. So when you add this sewage stream to this pure river water that has saturated oxygen, the saturated oxygen will get low. Why will it get low? Because some part of this saturated dissolved oxygen will be used in oxidizing the organic content present in this sewage. The sewage is full of organic content. This organic content will be oxidized because of this oxygen level. This oxygen will now reduce. See, this is shown in this curve. Initially the river has dissolved oxygen at its saturated point, okay. This represents, this curve, this Sag curve represents the point when you add the sewage to the pure river water. What happens? The dissolved oxygen reduces from the saturated to some certain point. This dip in the oxygen level is called as the dip. It is called as dip, and this dip is represented by D0. This is the symbol to represent the initial reduction in the oxygen level when you add the stream. Instantly जो भी oxygen में reduction होगा, that is called as D0. And similarly the oxygen gets on reducing and the organic content gets on oxidizing. This is the length. जैसे जैसे रिवर की लेंथ आगे आगे जाती जाएगी, सीवेज आगे आगे बढ़ता जाएगा और उसका ऑक्सीजन कम होता जाएगा. एक पॉइंट ऐसा आएगा जब ऑक्सीजन वापस से बढ़ना शुरू हो जाएगा और इस पॉइंट तक ये बढ़कर वापस पहुंच जाएगा. It will never attain D0 saturation at this point. यहां तक D0 saturation नहीं आएगा, इससे आगे वो saturation पर पहुंच सकता है. एक पॉइंट ऐसा होगा जहां पर इसका ऑक्सीजन लेवल जो है वो मिनिमम होगा. दैट पॉइंट इज कॉल्ड एज द क्रिटिकल पॉइंट. दिस पॉइंट इज द क्रिटिकल पॉइंट. और इसमें जो रिडक्शन है ऑक्सीजन लेवल का सैचुरेटेड पॉइंट से, उसे हम कहते हैं क्रिटिकल ऑक्सीजन डेफिशिट, एंड इट इज रिप्रेजेंटेड बाय DC. The examiner can ask you to calculate this value of DC, कितना ऑक्सीजन लेवल में रिडक्शन होगा. It can ask you the value of TC, किस पर्टिकुलर टाइम पे आपने यहां से सीवेज ऐड किया T इक्वल्स टू 0 से, तो किस पर्टिकुलर पॉइंट ऑफ टाइम पे ये मिनिमम पॉइंट जो है वो अचीव होगा. और ये मिनिमम जो DC है वो हमेशा आपका जो ऑक्सीजन लेवल डीसी के बाद है आपका ये वाला पॉइंट, ये हमेशा 4 ppm से ज्यादा होना चाहिए। अगर 4 मिलीग्राम पर लीटर से ये आपका ज्यादा नहीं है, सपोज कीजिए आपका ऑक्सीजन जो ऑक्सीजन है डिसॉल्व ऑक्सीजन वो इतना कम हो गया कि ये 3 ppm पहुंच गया, तो उस पॉइंट ऑफ टाइम पे फिशेस और एक्वेटिक लाइफ जो है वो खत्म हो जाएगी। दैट इज वाई the minimum oxygen level at any point of time should be greater than 4 ppm so that aquatic life is maintained. Now how to calculate all these things? See, this is the reoxygenation. When you add, the reoxygenation is minimum and deoxygenation is maximum. Deoxygenation means reduction of oxygen is maximum, and then the reduction depletion starts on decreasing and reoxygenation starts on increasing, and at this particular point, at point of equilibrium, we get the value of dc. Now there is a derivation, there is a very big derivation to calculate all these points like dc, tc and dt, but we will not go into the depth of the derivation and we will directly learn the formula. So this is the formula for dt. Dt means, if I ask you that what is the depletion in the oxygen, that is what is the reduction in the dissolved oxygen at t equals to suppose 1 day. After 1 day, what is the value of reduced dissolved oxygen? Then you have to calculate dt. Okay, you can calculate dt from this formula, kd into L divided by kr minus kd into 10 to the power minus kdt minus 10 to the power minus krt plus d naught 10 to the power minus krt. I will explain everything with the help of a numerical. Just for the time being, understand these terms. Kd is, what is kd? Kd is the constant, and this is the deoxygenation constant. Okay, what is kr? Kr is the reoxygenation constant, and both these constants are in the terms of 10 to the power. There is one natural and there is one in the powers of 10, so these are to the powers of 10. T is the time period, the time the units of t and kd should be, suppose kd is in per day, then t should be in days, and so on. What is d naught? D naught, I have already told you, initial dip in the dissolved oxygen level. So I hope this formula is clear to you. What is kd here? Now suppose you have to calculate tc. At what time this dc will be achieved? At t equals to 0, we poured the sewage stream in the river. At what time the minimum dissolved oxygen will be achieved? So this is called as tc. It will have the units of time. So kd you know and d naught you know. What you don't know is L and F. See, F is Kr divided by Kd. It's a self-purification constant. The greater is this constant, the greater the river achieves its dissolved oxygen at saturation earlier. जितना ज्यादा ये प्यूरिफिकेशन कांस्टेंट होगा, सेल्फ प्यूरिफिकेशन कांस्टेंट, उतनी जल्दी कोई भी रिवर जो है वो अपना डिसॉल्व्ड ऑक्सीजन सैचुरेशन का मेंटेन कर लेगी, क्योंकि Kr ज्यादा होने का मतलब है कि ऑक्सीजन जल्दी जल्दी रिप्लेनिश हो रहा है, Kd ज्यादा होने का मतलब है ऑक्सीजन जल्दी जल्दी डिप्लीट हो रहा है. सो द ग्रेटर द वैल्यू ऑफ दिस सेल्फ प्यूरिफिकेशन कांस्टेंट, द अर्लियर द रिवर विल अचीव बैक इट्स डिसॉल्व्ड ऑक्सीजन सैचुरेशन लेवल्स. Okay, so F is also clear to you now. What is L? L is the ultimate BOD of mix. BOD, ultimate of mix. Remember this, not of river, not of sewage. Suppose sewage has some BOD, river has some BOD, river has some discharge and sewage has some discharge. So you have to calculate the BOD of the mix by the weighted average formula. So this is L. Okay, and TC you know, this is TC. F you know, L you know, so you can also calculate the critical oxygen deficit level. So this is all about the brushing up of the formulas. Now let's get back to one numerical question and it will clear everything in your mind. So the question says that this is a question that has been extracted from one standard book, and this is a very good question, and just one question will be enough to complete the whole portion of this particular chapter. For a location downstream of a point of mixing of sewage effluent, there is one sewage effluent which is mixed and there is one river water that is mixed. So for sewage, the discharge is given as QS and it is 125 meter cube per second. Okay, this is one sewage stream and it is mixed with one river, and definitely the flow of river will be much greater than the sewage. So it is 1600 meter cube per second. Okay, and at some particular point critical deficit will occur. This is stated in the question. Definitely whenever the stream will be mixed, at some point there will be a critical deficit. Now the velocity of the stream is given as 0.12 meter per second. Okay, and BOD of wastewater, this is the BOD of sewage, and it is given as 300 milligram per liter. Now see, this BOD is not the ultimate BOD, since the question has just stated, as you can read, that BOD of wastewater is 300 milligram per liter. So that means it is the standard BOD, nominal BOD. Okay, now KD is given as, this is the constant, deoxygenation constant, it is 0.11 per day. Units should be taken care of. Similarly, KR is given as 0.44 per day. So from KR and KD you can calculate the self purification constant easily. Okay, and one more important thing is given as BOD ultimate. It is saying that BOD ultimate can be taken as 1.25 times of BOD standard. Okay, whatever is the BOD standard, multiplied by 1.25 and you will get the ultimate BOD. This is given in the question. Now dissolved oxygen of river is given as 9.2 milligram per liter. We can say this is the saturated. From the graph you know, this is the graph. This is the dissolved oxygen saturated, and this is for the river. And then there is an initial dip called as D0, and this is DC. You have to calculate this DC. Okay, so dissolved oxygen saturated is given, and in the previous video, if you remember, I told you that whenever the BOD of river is not given to you, then you can always assume the BOD of river as 0 and dissolved oxygen of sewage as 0 milligram per liter. We always assume that sewage is purely dirty and the river is purely clean of organic content. It does not has any organic content and it is full of organic content. Okay, so this is as per the assumption. Although in the gate the ambiguity is never kept, they will always give you this particular thing in the question, but in this question it is not given, so we are assuming it. Okay, now you have to calculate the DC. The value of DC has to be calculated, and the location of its occurrence, TC, has also to be calculated. So you have all the given data. You know, from the formulas you will require the value of L. What is L? L is the BOD ultimate of the mix. So to calculate the BOD ultimate of the mix, first of all you have to calculate the ultimate BOD from this standard BOD. So you know, ultimate BOD of the sewage will be 1.25 times 300. Okay, so this will result in 375 milligram per liter. Now how can you calculate the ultimate BOD of the mix? By the weighted average formula. This is 375 and the discharge is 125, plus the BOD of river is 0 and discharge is 1600, divided by the total discharge 125 plus 1600. Okay, so the ultimate BOD is coming out to be 27.1739 milligram per liter. This is a very important formula, a weighted average formula. This can be used to calculate the BOD of the mix as well as the dissolved oxygen of the mix, although we do not require the dissolved oxygen of the mix in this particular case. Okay, no, we will require. So we have to calculate the dissolved oxygen of the mix also, and that will be 9.2 into 1600 divided by this total 1725. Okay, so the dissolved oxygen of the mix is coming out to be 8.533 milligram per liter. See, when we mixed the sewage into the river, this is the value of dissolved oxygen. Highest dissolved oxygen was 9.2. So when we mix it, it gets reduced to 8.533. So what is the dip? D0. You can calculate the dip by DO saturated minus DO mix. So this is coming out to be 0.666 milligram per liter. I hope this point is clear to you. Okay, I'm rubbing this part. And this is the value of L which will be required in the question. This is L and this is D naught, initial dip. Okay, we can also calculate F by KR divided by KD, so it will come out to be 0.44 divided by 0.11. So this is the value of self purification constant. So let us first calculate TC. Okay, TC. So for TC, let me rub everything. So we have to calculate the value of TC. Okay, how can we calculate the TC? From the formula 1 upon KD into F log 10 F 1 minus F minus 1 D naught by L. So we have to put the values 1 divided by KD. What is the value of KD? 0.11. What is the value of, sorry, this is F minus 1. Okay, so what is F? F is 4, so F minus 1 will be 3 log to the base 10. Remember this. So this is 4, 1 minus 3 into what is D naught? This is the dip, 0.666. And what is L? L is 27.173. Okay, so when you will solve this, the TC will come out to be 1.723 days. So this is the value of TC. I hope this is one part of the question, and I hope this is clear to you. Now you have to calculate the value of DC. To calculate the value of DC, you require 1 upon F, this is the formula, L 10 to the power minus KD into TC. Simple. So this is 1 divided by 4, L is 27.17 and 10 to the power minus KD. What is the value of KD? The value of KD is 0.11 and TC is 1.723. So when you will solve this, the DC value will come out to be 4.39 milligram per liter. I hope this is clear to you. Now you have to calculate the location of this occurrence of this DC. So location can be calculated by this TC. You know velocity is given in the question. Velocity equals to distance upon time. So this is distance you have to calculate, velocity you know, time you know. Velocity is given in the question as 0.12 meter per second. You have to calculate distance, and time is 1.723 days. You have to convert this days into seconds, into 60. So distance will come out to be 17.87 kilometers. So this is the required answer. So these two things were asked in the question. Calculate the critical oxygen deficit. This is the critical oxygen deficit and the location of its occurrence. So this is the location, the distance. That means this is the river starting at a distance of 17.87 kilometers. The sag will occur, the maximum sag will occur. I hope this concept is completely clear to you all. Okay, the next question is from the previous year GATE question, and it was asked for 2 marks in the year 2005, and it is very simple. The characteristics are given and you have to calculate the mixture DO, the dissolved oxygen of the mix. So for wastewater, the dissolved oxygen is given for sewage and it is given as 2 milligram per liter. Just hold for a second. The dissolved oxygen is given as 2 milligram per liter. This is for sewage, and the discharge of the sewage is given as 1.1 meter cube per second. Similarly, the dissolved oxygen of river is given as 8.3 milligram per liter, and the discharge of the river is given as 8.7 meter per second. So you have to calculate the DO of the mix. So it will be 2 into 1.1 plus 8.3 into 8.7 divided by the total discharge 1.1 plus 8.7. So when you will solve this using a calculator, it will come out to be 7.6 milligram per liter. So this is the required answer, and the option is C.